Hello everyone, welcome back to MacTech 40 and today we will see one question of SSC JEE. Okay, this question is very good conceptual question. So and the level of the concept that is asked at the gate level exam. Okay, so don't underestimate it that SSC JEE will not ask any small the big questions like this. Not this is not a big question, but this is a conceptual question. Okay, so don't think like SSCJ will only ask one liner. Okay, so the question, let me see. A closed system contains saturated liquid ammonia. Here we have to go word by word. Saturated liquid ammonia at 10 degrees Celsius. The mass of ammonia is 5 kg. The amount of heat that is required to convert all the saturated liquid into vapor at constant pressure, that is 16.2 megajoule. That means it is a vaporization process. And in vaporization, or you can say that phase change process, the temperature as well as pressure both remains constant. Okay, if the entropy of saturated liquid is 0.88 kilojoule per kg Kelvin, entropy of saturated liquid, okay, then we have to find out the entropy of saturated water. Sorry, not saturated, what vapor of ammonia, not water. Okay, it's my mistake, sorry for that. So we have to find entropy. Now what we have to do? So this question is very good. So we know the equation of entropy, the basic equation of entropy, that is entropy change for any system. Okay, this is the closed system, that is equal to heat transfer divided by at particular temperature if temperature remains constant. Okay, this is general equation if the temperature remains constant. And why we can use this? Because it is a vaporization process, and as I explained you earlier, that is in vaporization or phase change, the temperature remains constant as well as pressure. Okay, now the suppose this is a TS diagram. Here it is a saturated liquid point, and here it is a saturated vapor point. So this is the process that has been undergone by ammonia. Now at this point entropy is given, entropy of liquid. We have to find entropy of vapor or SG, gaseous. Okay, now the amount of heat that is given, it is 16.2 megajoule. Okay, so this is not a single, this is a heat change. Okay, this much amount of heat difference. So delta Q, it is given in the question, that is 16.2 megajoule. Now what happens? Entropy change, that is we can write the difference as entropy of gases minus entropy of liquid for any phase change. Okay, you know very well. And this is a specific entropy, so we have to multiply with mass also, and this T will come on the left side, so it will become m into T multiplied by specific entropy difference is equal to delta Q. Understand? So what is the mass? That is 5 kg of ammonia. Temperature is 10 degrees Celsius, but unit of entropy is given in kilojoule per kg Kelvin. Kelvin. So we have to multiply 10 degrees Celsius into Kelvin, so it will become 283. Now entropy of gas we have to find, or in entropy of vapor form. Entropy of liquid form is given as 0.88 kilojoule per kg Kelvin. And what is the heat transfer? That is 16.2 megajoule. So we will convert into kilojoule. Why? Because our final answer that we require is in kilojoule per kg Kelvin, and the given entropy of liquid is also kilojoule per kg Kelvin. Okay, so now just put all this thing on the other side. So you will get 16200 divided by 5, that is 5, because now today we will not solve in calculator, because in SSCJ you will not get any calculator. So we will cancel out this by 5. 5 3s are 15, 1, 5 2s are 2, 3240 divided by 283. So now what to do this in this case? Just try to apply the key of 3. So this is not also applicable, so just go by manually. Okay, so we can write as a 283 tens are, so we can directly write 283 ones are 283. So what is the difference between 283 and 324? That is 41. So 410 remaining and 283. So 283 twos are, it will greater than 410. So we have to just approximate 1. So there will be 11 point something. Okay, 11 point something. So 410 minus 283, 127. Now point, put a point and take out the 0 here. Okay, so what happened? 1270. So now we have 1270 divided by 283. So if you take the 283 fives are, then it will become, so it will be 1415. So it will be very high. But if we take 1283 fours are, then it will be very appropriate. So 11.4, and we have to add this 0.88. So SG will be 11.4 plus 0.88. So it will become 11 point, sorry, 8, 12.28. So Sg will, the entropy of vapor, that is 12.28. In question the answer is 12.32. That is very near to our answer. Okay, so this is the answer of our question. Hope you guys clear. The main concept is this and how to use this. Okay, hope you guys clear this, and all the best for your, those who qualified for ESE mains. Okay, so all the best to all the ESE mains 2020 candidates for to tomorrow's exam. Okay, and don't be panic, just go and read the paper first. Okay, and question number 1 and 5 are compulsory, so don't waste to look at the questions of it. Okay, because you have to attempt it. So just in within 5 to 10 minutes, just first decide which question you have to attempt. Okay, then start writing your answers. Okay, this is, I will give you the advice, and be the point to point. Okay, don't try to read like don't try to write unnecessary things. Okay, the writing of things only necessary, that is for numerical given data, then equation, then calculation, then final answer and conclusion. And in theory, if you have very specific time, then first write your main content or draw the figure, very basic figure, not very advanced figure. Okay, the basic figure, like for example working of centrifugal pump or expansion valve in previous year question. So just draw the basics, not fully body diagram. Okay, just only basic diagram that explain itself. Okay, self explanatory figure you have to draw, as well as uh, you have to mention this, all the things that you have assumption. Okay, if you take any assumption and that is not given in the question, so you have to write separately also. So this thing you have to remember before the exam. Okay, so once again, all the best guys. Tomorrow we will solve the questions of ESC mains 2020. We will try that our channel will, on our channel we will solve first on YouTube. Okay, so we will meet tomorrow. Till then, keep studying, stay focused.